All right, today we are diving into a really cool concept, something I like to call a secret weapon for writing flexible, dynamic code. We're talking about the function pointer. Now, I know it sounds a little intimidating, but trust me, it's an idea that can totally change the way you build software.
So let me just start by asking you this. What if your program wasn't stuck doing things in one fixed way? Imagine it could adapt, change its behavior right in the middle of running, all based on what a user does or what's happening in the system. Well, that's exactly the kind of power that function pointers give you.
So here's how we're going to tackle this. We'll start with a super quick refresher on functions and pointers, just to make sure we're on the same page. Then we'll see the magic that happens when you put them together, look at how to actually use them, and finally, get into why this is such a huge deal in the real world.
Okay, let's jump right in. What on earth is a function pointer? I promise, despite the name, it's way more straightforward than it sounds. It's really just about combining two concepts that you probably already know.
And look, the trick here is to not get bogged down by the name itself. We're just going to break it apart. First, we'll look at the function part, then the pointer part. Once those two are crystal clear, putting them together is going to feel totally natural.
So first up, functions. These are the absolute building blocks of pretty much any program you write. They're the little engines, the action verbs that get things done. At its core, that's all a function is, right? It's a self-contained chunk of code that does one specific job. You give it a name, you write some instructions, and then from anywhere else in your program, you can just call that name and boom, those instructions get executed. A great analogy is to think of a function like a recipe. Let's say you have a recipe called Bake a Cake. It has a name and a list of steps. Now, every time you want a cake, you don't rewrite the whole recipe from scratch, right? No, you just turn to that page. Functions do the exact same thing for your code. They let you reuse instructions.
Okay, so that's one half of the puzzle. Now for the other half, pointers. If functions are all about the action, pointers are all about the location.
So here's the key difference. A normal variable holds a piece of data, like the number 42 or the word hello. A pointer doesn't hold the data itself. Instead, it holds the memory address, the exact location where that data is being stored. Think of it like this. A pointer is like writing a home address on an envelope. The address tells you where the house is, but the piece of paper itself isn't the house. It just points you to it. That's all a pointer does. It tells your program where to find things.
Okay, so we've got our two ingredients, functions, which are our recipes, and pointers, which are our addresses. Now, let's see what happens when we mix them together.
And here it is, the big reveal. It's actually incredibly simple. A regular pointer stores the address of data. A function pointer stores the address of a function. That's literally it. When your program is built, all those functions you wrote get stored somewhere in memory, and a function pointer is just a variable that holds the address of where one of those recipes begins.
So, let's bring our analogies together. If your entire program is a cookbook and all your functions are the recipes inside it, then a function pointer is basically just a sticky note. You write a page number on it, say page 73. The sticky note itself isn't the recipe for chocolate cake, but it tells you exactly where to find it.
So now we know what a function pointer is, but how do we actually use it? How does this make our code dynamic? Well, this is where a little concept called call by address comes into play. This is just the fancy term for it, but all it means is that instead of deciding ahead of time exactly which function to run, we pass its address around. We're essentially telling another piece of our code, hey, I don't know what you need to do yet, but when you're ready, the instructions are at this location.
And it all boils down to these three simple steps. First, you declare a special pointer variable that's designed to hold the address of a function. Second, you assign the address of one of your actual functions to that pointer. And third, you just tell the pointer to run. And the real magic is that you can change what that pointer is pointing to at any time. Think about it. The alternative is probably a giant messy if-else chain, right? This is just so much cleaner.
Okay, this all sounds pretty cool in theory, but where does it actually show up? Why should you care? Let's talk about the real world.
The main takeaway here is that this one concept, just combining functions and pointers, unlocks a whole universe of powerful ways to write code that's responsive, that's customizable, and that's modular.
I mean, you see this everywhere. Think about any button you've ever clicked in an app. The button itself doesn't know what to do. It just knows that when it's clicked, it needs to call the function at the address it was given. That's a function pointer. This is the backbone of things like callback functions, plugin systems where you can add new features without changing the core program, and tons of advanced design patterns.
And that's the ultimate goal, right? You can write one generic piece of code, but make it behave in dozens of different ways just by pointing it to different functions. It's the key to making your code super reusable and adaptable. Now sure, the trade-off is that it can sometimes be a little tricky to debug, because you don't know exactly what code will run until it's actually running. But for the flexibility you get, it's an absolutely essential tool.
So I'll just leave you with this thought. We just saw how taking two simple things, functions and pointers, and putting them together creates something way more powerful. So my question to you is, what other basic ideas in programming could be combined to unlock something totally new? It's a fun thing to think about. Thanks for joining me.